Pop quiz. Looking only at the very start, which reaction has the greater initial rate? A, B, or are they the same? Lock in your answer. We'll reveal it soon. In this video, you'll learn what rate of reaction means, how we measure it, how to find average and instantaneous rates, and how rates for different substances are linked by stoichiometry. After a reaction occurs, the rate tells us how the concentrations change over time and is always reported as a positive number. If the reaction is determined based on how much reactants have been used up, it is called the rate of disappearance and is written with a negative sign to make the result positive. But when the rate of a reaction is determined by how much product is formed over time, the rate is called the rate of formation and is already reported as a positive number. Ultimately, whichever approach we employ, we describe the rate as the change in concentration divided by the change in time, and report the answer as a positive number. We can track rates in many ways. If a gas forms, we can follow the pressure. If a colored species appears, we can monitor light absorption. Ionic changes can shift conductivity, and gas loss can show up as a decrease in mass. Different signals, same idea. Concentration change over time. Let's work one example. Consider the decomposition of dinitrogen pentoxide in solution. Over the first minute, we compute the average rate of disappearance by taking the change in its concentration divided by the change in time. Because it is a reactant, that change is negative. The magnitude tells us how fast it is being consumed. To compare species, we scale by the stoichiometric coefficients. Here, the overall reaction rate equals -1/2 times the change in dinitrogen pentoxide per unit time, equals +1/4 times the change in nitrogen dioxide per unit time, equals the change in oxygen per unit time. Signs track direction. The fractions come from the balanced equation. A common mistake is to compare raw slopes without scaling. Do not forget to divide by the stoichiometric coefficients and to use negative for reactants and positive for products. That is how different species rates describe the same overall reaction speed. So far, we defined rate as change over time, saw common measurement signals, and linked species using the coefficients in the balanced equation. Curious how much you're remembering? Your personalized practice test, flashcard set, and study guide are all waiting for you. Just tap the link now and keep watching. Future you will thank you. Now, let's try our learning on a new case. If oxygen disappears at 0.030 moles per liter per second, hydrogen disappears twice as fast because of the 2-to-1 ratio. So, 0.060. Water forms twice as fast as oxygen disappears. So, its formation rate is plus 0.060. Average rates use finite intervals. Instantaneous rate means the slope of the concentration curve at a single moment. The initial rate is the instantaneous rate right at the start. Graphically, you draw a tangent line and read its slope. Short time windows can approximate it when data are noisy. Watch out for some pitfalls. Make sure your horizontal axis is time when you talk about rate. Include units like moles per liter per second, and for a reactant, do not drop the negative sign when you report a change. Reserve a positive value for the standardized overall rate. Now, let's apply what we learned. First, choose a species and either an interval or a time point. Second, compute the change or draw a tangent for a slope. Third, attach the correct sign. Fourth, divide by the coefficient to state the reaction's rate. Fifth, convert to any other species using the same master equality. Hence, to answer the pop quiz earlier, the answer is A. The initial rate comes from the slope at time 0. The steeper the drop in concentration at the start, the faster the reaction at that instant. To recap, rates measure how concentrations change with time, scale rates by the inverse of the coefficients, and use signs for direction. Average rates use intervals. Instantaneous and initial rates come from the slope of a tangent line. Ready to quiz yourself with the content covered in this video? Check out the link in the description where you'll find Quizlet content made just for you.